Hello, everyone. Good morning. We are live. My name is Jose Barbosa, and this is the .NET Bangkok Meetup. I am your host for today. Sawadee krap, everyone. Sawadee krap to com. One ipem .NET Bangkok Meetup Sisip Rock. Ponto José na krap. E hoje, and today we are going to have four talks. Today I'm from Brazil, not currently in Bangkok for this month as I'm in holiday, and we are going to do a very special meetup for tonight, right? And for today, we have four talks, right? I will share my screen with you right now. Let me put yes, this one here. And I would like to tell you how we are going to play the meetup today. Today we have four talks. We are going to start with the two talks from Brazil, speakers from Brazil, and two talks from speakers from Thailand. So I would like to say a big thank you for all the speakers, Victor, Giovanni, Will, and Pete, right? And just some before we start with the first talk, just some announcements and the reminder as always, right? This is the .NET Thailand community. We are a passionate community of developers. Usually work with .NET technologies. We are very active in the. We have meetups monthly, right? So every month you can join us to discuss and learn about .NET. We also have our .NET Thailand page. So if you don't know or you never check it, please check and also help us to spread the word. Invite your friends and introduce this for your friends, and also our .NET Thailand Facebook group, right? Independent, what is your favorite social network? You can reach us. And just to let you know, we are always looking for organizers and speakers. So you would like to contribute with the .NET Meetup, just let us know, okay? And so this is all of our links, okay? And for today, we are going to have four talks, okay? So the first one, I will invite Victor to the stage, and let's start. Hello, Victor.
Hello, good morning or good afternoon, good evening, depending on the time zone.
That depend on the time zone, right? So it's around 7 p.m. Bangkok time. Will be a good evening. It's around 9 a.m. Brazil time. So good morning for us. So we have here Jose Barbosa and Vitor Barbosa. Vitor, as soon you can share your screen, we can start. Okay.
So let's go.
Mm-hmm. Okay. So
Okay.
I see your screen here. I will edit. Yes, you can see. Okay, perfect. I will be leaving the stage. You have half hour, and good luck.
Thank you.
Take care.
So, hi, my name is Vitor Barbosa. As you can see, I'm not related to Jose, just a common last name here. I'm a senior consultant at Thoughtworks, and I'm going to be speaking a little bit about minimal APIs with .NET 6. We're going to do a little bit of a demo as well. So first up, what? So minimal APIs are basically APIs that don't need a controller. Uh, that's the main definition here. It's really that simple. Uh, and why? There's a few reasons. So they were built to reduce complexity, which is going to help newcomers. If you've helped people get started with .NET, they're always going to be a little bit taken aback by how many files and how much code, how much boilerplate code you really need to get started with a simple hello world. They're going to reduce, so minimal APIs are also going to reduce ceremony, which helps everyone. And they have a really strong focus on being minimal. The words there, it's for a reason. So just to give a little bit of a comparison, this is what typical controller would look like for a brand new project up to .NET Core 3.1, latest LTS version we had. So yeah, we're gonna have a few dozen lines of code just on the controller side. Also on the startup class, we're gonna have almost 50 lines. There's some empty lines in there, but still it's a lot of a lot of boilerplate, a lot of code for a beginner. There's a lot of things they don't understand. They don't really know why they even need it. And with .NET 6 and minimal APIs, Hello World became just 3 lines of code. It's really that simple. I mean, the minimum is from there. So you can get, with 3 lines of code, you can have Hello World, your first API going. And we're going to do it right now as well. So install .NET 6. I already have .NET 6 installed. I have an empty folder here, as you can see, and we can just do .NET new web, which is going to create a new project, new empty project, simple, ASP.NET Core empty project is going to be created. From here, we can already do a .NET run. I'm going to show you the project in just a little bit. It takes a second to build on the first time. Going to restore the package dependencies, do the first build. And here we go. Open on the wrong screen. See, we already have this address. We already have Hello World. It's already going. And our project, let me open up on code. It looks, it looks like this. Oh, here it goes for 4 lines of code just because we have a builder separated. It's not really needed for just a Hello World, but in a little while we're going to need it. So we're going to be adding a little more stuff. So let's take this back. Sorry. Now we're going to add a little bit more to this. So really, we're going to add Swagger as well. So, add package swashbuckle, .NET Core. This is still the same as we had in previous versions of .NET, so it's not okay. So I'm just gonna add this code really quickly, as there wasn't much change, but Swagger is gonna help us test out our new APIs, whatever we add. We're gonna have a good interface for seeing it and for testing and doing the rest of our demo. Do Swagger UI. Okay, this is a little bit more, but again, we can .NET run. And now we have our Swagger page. The same, showing just the same first API we have. So for now, it looks still very similar. We're going to add a few more packages. So we can add a little bit of a database for our project. For this purposes of this demo, we're just going to add the in-memory database, entity framework. Just so we don't have to worry about connection strings, installing the database, that sort of thing. And the code's going to look very similar to what we have with if we had a full-on project, a full database, sorry. Okay, so from here, we can start doing a little bit more code. We can add a class, we can call it person. And we'll just have a few properties to get started. We can have first name, and last name. That's enough for us. We're also gonna have a DB context. Okay. It's just gonna have instructor, context options, or self options. Okay. just a very simple DB just to get it started. Really set. Gonna call people, and it's gonna return a set. Okay, that's our first one. So we obviously need to add this DB context to our services, right? So this has been simplified with minimal APIs. So we just add the DB context for people DB. Just a couple lines of code, we're going to get this going. We can specify we're going to use in-memory database, as I said before. Just to keep things simple, we don't need to write any more services on our machine for this demo. And we can also add a database developer page exception filter. So if we make any mistakes, we can see them a little bit better. Okay, so now that we have this PeopleDB added to our services, we can use it to add more endpoints. And it really is just as simple as we can map a new get with an address like people. Let's say because it's going to be async, and it's going to use an instance of PeopleDB. And this is going to return DB people to list async. Sorry, here. That's it. That's our first one. We're still not going to have anyone on our database. It's still going to be an empty list, but the first one is done. I'm going to add a few more so we can see everything a little bit better. We can add a person before we, so we can really try and see, make sure that everything works. Right. So if we're going to get a single person, here I can add URL parameter for an ID. And then it's very similar to the one above, right? So right here, I have the same ID with the same name as before. It's going to be mapped to the same variable. With this, I can just await people find async, passing on that same ID. And if we get a person from this, we're going to define our first results. So we have this results.OK, and passing our person that we found. And of course, if we didn't find anyone, we're just going to return the results not found. So it's really that simple. We already have here the API. It's going to look for people in our database. If it finds them, it's either going to return OK with the person or not found. We also have to create a new person. We're going to do backup post. So same as before, this time we're going to receive a new person as well. We want to add it to a database. We also have our PeopleDB. For this one, I may want to open a few lines. Find it something, sorry. So we're going to add a person. Save changes async. And we can already return our results. Now we're going to use a created method for a person. Already use the ID that we received from a variable, and we're going to return the person. Okay. Oh, this is just missing a semicolon. Sorry. We can do put to update. So we're going to do the full update, retrieve, update, delete, because it really is simple and super quick to get everything going. So here we're just going to go with people. Same as before, we're going to have the ID. Just do it sync. we have the ID. We're going to have input person as well, and our DB. For this, I'll wait. We're going to try to find this person before, so to update, we have to make sure they exist. We can do, if we didn't find anyone, we're going to return the same results not found we used before. Then if we did find the person, we can update the last name and the first name. We're gonna wait to save changes. And another method we can return from results is no content, probably this one. Semicolon here. Just one more delete, and then we can show everything working. Oh, not delete. Here we go. Delete. Also the same, we're going to pass ID as a parameter. ID, we're also going to operate on our instance of our PeopleDB. And here we're going to try to find the person. We need to make sure they exist before we can delete them from our database. And we can call a remove person, save changes, and we're going to return okay. With this person that was deleted. And then, of course, if we didn't find anyone, we're going to return not found, 404. And that's really it. So in 70 lines of code, we have the 4 operations going for our people. Let's run this, see if everything still works. Let's get building. Here we go on our Swagger. We're still running on the same address. You can see Swagger already created our has here a full list of endpoints, everyone we created. So we're going to say, you can see the parameters. If we get everyone, it's going to return an empty array. We haven't added anyone yet. We're going to add a new person, first one, to our database, make sure everything works. Add myself. Okay, and then if we try again our get everyone, we already receive our first person. If we try to get a person by ID, let's throw in an ID that doesn't exist. Expecting we're going to get a 404 not found. That's the one. And then if we try with an ID that does exist, we're going to get 200, success, get the return. We can delete a person. Let's try this out, same as before. Get a 200, so that's a success, so we deleted. So it looks like everything's working. We get people again, we see it's an empty array. Oh, we didn't try put, so let me post a new person, but make some typos. So maybe my keyboard got stuck or something and you made an error. So we added a person with the ID of 1, so we're gonna update it. Put ID 1. We don't really need to pass in ID again. Sorry. Here we go. That's the first and last name that we're gonna correct. So we can do a put, returns no content. That shows us really quickly that we have, let me even do a get on person again, so we can see the right results. Oh, I didn't update the first name. Looks like I make a little mistake. Last name was updated, first name not.
Yeah. Yeah, just one comment about that, Victor. There is a typo on line 39. If you go on line 39, you are going to see 39 is input person
Yeah.
first. Yeah.
Yeah, thank you.
No worries.
Person. Thank you, Jose. Yeah, that's why I was just getting the same value again. So we weren't updating anything. We're just using the same. Okay, so that shows basic for operations: create, retrieve, update, delete, going on really quickly. Just a few lines of code. Of course, if you're going to have a bigger project, you're going to have a bigger database, a little bit more tables, more variables. It's going to be a little bit more. Okay, but that's good. So what else can we do with the minimal APIs? Go back to my slides. DB we've done. Create, retrieve, update, delete is also already done. We can add some validation. Yeah, there's we can use this package. Sorry. For mini validation and add some validation really quickly. We can even validate our inputs, so it doesn't need to be accepting invalid values, or maybe you're going to have something that's required. Okay, it's also already added. We can do some changes to our code base really quickly. Maybe we want to say that first name is always something that's required. Right, we're going to use system model component. And we're also going to say it has a minimum length of 3. Maybe your database first names always have to have a length of 3 at least. Seems reasonable. Here we're also going to be using this new package we installed, mini validation. For this, we're going to create a new endpoint just so we can distinguish it and return errors when it's not validated. We can see some differences. So this is going to be called people validated. Very similar to the first one. We're going to have a DB. This. And then we can call on mini validator. Try to validate a person. And it's going to have some errors for us. So if the validation passes, we know we didn't have any errors. We can add the person. We can save changes. And we can return. It's actually, return is here. Return line. But if we do have errors, then we can return the validation problem. And we are actually ready to test this out. It's really that simple. Let's run again. Oh, I made a mistake, I think, on the code base. Let's go back. Oh, it's just missing the return. Okay, so go back to our Swagger. We can reload. And we have people validated. So here, as our requirement was for first name with at least 3 characters, if we have first name with just 1, we're going to return validation errors. And it's really simple for you to build an API, so your consumers are going to know the errors was in the first name field first name, must be a string, minimum length, all your requirements are there, and you can show the validation really simply for consumers of your API. And going back here, we have a few quick takeaways from this. That minimal APIs are great for proof of concept stuff, prototypes, and if you're going to be working heavily with microservices, it's really quickly to get a microservice going off. So they are really not built to be a replacement for other frameworks. Everything still exists. You can still grow your app when it's necessary. You can still build it with controllers in the way we've been doing .NET for many years. And you can grow your app if it gets necessary. If you're not going to do microservices, if you're going to be building this up into a full-fledged enterprise application, you can also do that. Minimal API still supports MVC features, still supports everything. There's no so it's a new, easier way to get started, quicker, but it's not a full replacement. It's a lot of work has been done with the new templates like .NET New Web to get this started. Remove a lot of the boilerplate. Oh, a question I've seen people ask the first time they see this is, so where's the using statements, right? We only have a few using statements and the rest are not here. So these are going to be added by the compiler. You can see them here. In this global usings is going to be generated. So we don't need to add Microsoft Testnet Core Builder. We don't need to add using Microsoft Testnet Core HTTP and so on. All that stuff's going to be added by the compiler automatically for us. And well, that's the last one. So I just want to thank you. Thanks everyone. From Thailand, from Brazil, everyone that's listening. My name again is Vitor Barbosa. You can find me on Twitter. It's the same user, and GitHub's the same user as well. Please reach out if you have any questions. You can send them on the chat as well. I'll be checking there, sending any links, anything you want. Okay.
I mean, yeah. Thank you very much. Thank you a lot. Amazing presentation. Very good live coding, right? There are some questions on the chat, right? I will be pulling out to you, right? The first one is from myself. I saw that you used the what database page exception filter, right? Um, can you tell us a bit more what it does? I imagine that would be similar with the exception, a developer exception, but we'll add some database specific things. Can you detail a bit for us?
Yeah. Basically, that's going to be it. It's going to add that yellow database exception page that we've seen happen a few times. If you do if you have any exceptions saving to the database, timeouts, anything like that, if we're going to have any constraints on the database side, we're going to see that exception page added for us. That's probably something you're going to want to add maybe to if you're using a development mode, or if your environment's in development, you can use that. Of course, you can add logging. You can add more stuff to this. It's really a minimal sample.
Mhm. Okay, that's cool. That's nice. There is one other question. I see this kind of questions a lot. Uh, Talk about that. I would like to say hi for Peter, always here with us, right? So Peter is asking, you share some thoughts in your last slide, but would you use minimal APIs anywhere? would you deploy this production, or this is something used only for prototyping and teaching, right? For larger APIs, the lack of controller like abstraction feel a bit messy and harder to test. What are your opinions about that?
Hi, Peter. Yeah, I agree a little bit. I think this can be used a lot in actual production code. I think one of the biggest use cases is going to be for microservices. So if you have something that's really small, it's going to be a couple of endpoints. I'm building a service right now, actually, for work that's just a couple of endpoints, API endpoints, and we're going to have a lot of the work's going to be done by Azure Functions. So just this few endpoints, it's easy to get this started. It's easy to test. You can also add tests to a minimal API project. It's not a lot of work to do that. Not a lot of overhead. It's easy to test, so it can be used. But yeah, if you're going to grow to a lot of controllers, I would want to still add a separate folder, add some classes.
That's nice. That's nice. Just some other comments about that. If you put your lambdas inside the functions, will be a little bit complicated for that. But one thing that I've been seeing a lot of people do is literally API a la Node.js Express, right? Where you create a file called route or something like that, and you put the functions that are going to handle that route, right? So when you are going to test the controller, you basically only call that function. And I kind of agree with you, Victor. Take care for don't do a God class, right? A God API in a minimal API, right? But I really like I like heavy options. I really do like heavy options. So before, if I want to do just some prototype and some teaching, right? I really could not create something really like that, right? So simple, fast, in the same file and with a view like that. And well, for microservice, fits completely well. Victor, any other comment? Anything else?
No, for me, that's it. Thank you very much.
Okay. Uh, are you interested to learn how to say "hola" in Thailand? In Thai,
Yeah, yeah,
we
sure.
say "sawadee krap." Sawadee krap. Saw.
Sawadee crap.
Yeah, perfect.
Wow.
Amazing. Thank you very much, Victor. So, see you. See you. Take care. Bye bye.
Thank you. Bye.
Okay, everyone. This was our first talk. Now we are going to follow up with our second talk of the night or of the day, depending where you are located. And for this, I will bring the infamous Giovanni Bass to the stage. Hello, Giovanni.
Jose, how are you?
Hello, I'm fine. I'm great. Thank you very much to join us this night. We are very happy to have you here.
Thanks for having me and good morning.
Yeah, good morning for us. So, Giovanni, I assume you want to share your screen. I
Yeah,
can add
let me do
on
that.
the screen uh, while Giovanni share his screen. Uh, I can see it now. Okay, Giovanni, are you ready?
Yep.
Are you ready? Okay, so the stage is yours. Good luck. See you in the end of the presentation. Bye bye.
Bye bye. Hi everyone. It's nice to be here talking to you. I hope we can. I can at some point be in Thailand to meet you all and in person. Hopefully when all this pandemic is over, and maybe do this uh, all together. Well, I'm going to be discussing source generators. You can find me online at Giovanni Bassi on Twitter, but I'm usually tweeting in Portuguese, so that might not be so helpful. All the information from this presentation is going to be on the link that you can find on the QR code on your right. And I'll show this QR code and the proper link in the end of the presentation again. So let's move forward. Just introducing myself quickly. I work at Lambda 3. It's a company I founded 12 years ago, yes. And I work as a software architect. I've been a Microsoft MVP for 12 years. My day-to-day work is in development. I'm coding daily. And I'm also a rock climber, a cyclist, a motorcyclist, an amateur drummer, and an amateur mechanic. I've been speaking online for several years now, and that's it. Let's move to the next one. Lambda 3 is a company that does software development for other companies. We've been working with .NET since the beginning, and we were very happy when Microsoft decided to make it open source and multi-platform, so cross-platform. So that was a nice thing to see. We've done stuff with all these technologies. We have a podcast. It's also in Portuguese, so I'm not sure if it's going to be helpful for you all, but it's something we do, and we like to be involved in with the community. So this is something we publish weekly, and we have open positions. They are also remote, but you do have to speak Portuguese. So we have positions for Angular, React, .NET, and all that stuff. The link is in the bottom right if you are interested. So, okay, let's dive in. Let me introduce source generators. Source generators are a feature from the compiler that allow you to generate code from existing C# code. So you are actually generating more code. You are adding to your project. It does not change existing code, right? So any source generator you create will add to your project and can't change any existing code. It's a way of metaprogramming, but it's still a very simple one, right? When we discuss metaprogramming, it's common to discuss also changing code, but source generators are not currently able to do that. There is discussion to maybe allow it, and they deemed the compiler team deemed it too complicated, so they are postponing it. It might happen, but we don't know. It's the code you produce from your existing code, the source you generate, is compiled with the rest of your project during the normal process build, and you have tooling support and all of that. It was released 2 years ago, actually. No, almost, yeah. Well, it was in the end of 2020, right? So almost 2 years with C#9. But it's not considered a part of the language. It's a compiler feature. Okay, the source generators didn't directly change the language. There were features that were added to C# to support source generation, but the feature itself is not a language feature. So you won't be seeing new syntax here directly related to source generators. So what happened is this, diving into it, and we are going to dive in a little bit into the compiler because this is mostly a compiler discussion. I'll show you some examples as well, but we'll be closer to the compiler in this talk. So you get a file, and you get a source generator, and in the end you have your DLL, right? So what you do is the file is going to be parsed, and a concrete syntax tree is going to be generated. For you who know what an AST is, an abstract syntax tree, a concrete syntax tree is the same thing, but with added information, right? You can go from the CST back to the source file. Exactly, they are round-trippable, okay? Then you compile from the CST, right? And you produce the compilation, and the CST is fed back to your source generator as strings. No, I'm sorry, as a CST, right? And you produce strings which are parsed back in the compiler, which generates an additional, well, it's a new version of the CST with all the new code that you produced. This new CST will produce a new compilation. All these objects are immutable in the C# compiler, so it's always a new version, right? And at the end, you're gonna emit the final code, which will be the intermediate language, so the IL, and then you got your DLL, right? So that's how it goes. You might not need to emit. You might not need to go all the way to the DLL, but the build process is this, right? So when you are working with Visual Studio, the last steps are probably not going to happen, only when you demand a build. But whenever you are typing, all the whole process happens all the time during there's a compilation, a constant compilation and an incremental compilation that happens in Visual Studio for you. So this incremental compilation is a thing for since the first version from Roslyn, which is like almost 10 years old now, maybe already 10 years old. Yeah, and that's why how they keep the typing and all the tooling features so fast, right? So it's in this incremental compilation, and the whole source generation thing, it plugs into this incremental compilation, and it's also the same using the same infrastructure for Roslyn analyzers. So if you know Roslyn analyzers, it's actually very similar to how that works. And actually, source generators are published as analyzers, right? So you take dependency on generators as analyzers. So you can have code existing on disk if you want to, but usually it won't be. So there is this property emit compiler generated files, which will be able to show you the generated files. But otherwise, they are not. They are just going to be in memory. Installation is done for source generators on via NuGet. So you write a source generation library and you publish it to NuGet. It's as simple as publishing a library. You can also reference a DLL, and so you could have an in-project source generation, a source generator. It's not very productive. I wouldn't recommend it, but and they should. There is discussion to make this in-project source generation easier, but at this moment it's not very good actually. So source generation at the moment is dealt as it's like a tool you produce and then you take a dependency on it later on, right? So having it in project is not very convenient. I'll show you in a moment why that is. A project may use several source generators. You can use source generators with analyzers, and all that works fine. And generators can make the build process slow. So if you're building source generators, you have to be careful, right? And if you take too long, the compiler will actually time out your generator, and it won't run. So you have to be careful. The current status now with C#10 is that it works reasonably well with Visual Studio, VS Code, and Rider. It didn't used to work well with Visual Studio Code, but they fixed it. I don't know when they fixed it, but it's fixed now. Before you would get compiler errors for the added code, but you don't get... Actually, not compiler errors. The build would work fine, but in the editor, you would see false errors that were not supposed to be there, and that's not the case anymore. Development of source generators is not yet very productive. You can be productive if you use unit tests, but when you really want to run it, it's kind of slow to get that to work. But recently they enabled debugging, which made it easier as well. We couldn't debug before. Now it's been, I think, maybe 6 months we are able to debug source generators. It's well implemented, it works and can be very useful. New features are expected in the next compiler version, so this is an evolving feature. Since Visual Studio 16.9, I think, they are showing source-generated content directly in Visual Studio. So you can go to the analyzers area in your Solution Explorer and expand it, and you're going to see the generated files. You can click on it and see it. They're not going to be on disk, but you can see them. Some ideas for source generators, just so you can have why this is useful, right? So you can replace reflection code. So, for example, fill a dependency injection container. If instead of doing that during the application boot, you could do that before when the source generator runs a static analysis and already creates the code that will fill your dependency injection container. It's also easier to inspect what's going to be in it. This is actually a real-world example, and I'll show you a little project I have done. Our demos are exactly with this use case. You can process external files, and the real-world example is Razor Views. Razor Views in .NET 6, they actually use source generators, right? And also their new JSON, logging. No, not the new JSON. The new logging in .NET 6, if I remember correctly, it's also using source generation and getting much faster because of it. And also for write boring code, right? For example, I notify property changed. Implementing it is usually pretty boring, and you can actually write a source generator that will do it for you, right? So you can. It will get clear in the next slides on how to do that. For example, here you can generate code from external files. So C# has always had this property, additional files, and you can add it. And then you can do in your source generator, you can for each in your additional files and generate source. For example, you might have some XML with something that you want to generate from, and then you can do it. You can use partial classes to actually hint your source generation. So what you do, you create a partial class and you add partial methods, and you let the source generation actually fill in this the partial method implementation. But the problem is partial methods must return void, not return values, and not have access modifiers, right? So this creates a problem. For example, here you have a partial method called method, and so your work is gonna happen on foo.cs, right? And then on foo.generated.cs, you can implement whatever you need using all your source code as basis to fill into that method. But that won't be able to, that wouldn't be able to do any of the things I mentioned before. But that has been fixed. That has been changed in C# 9. Right, so these are the features that were. This was a feature that was changed to better support source generation in the language. Right, so C# 9 was changed to allow partial methods to return values and have access modifiers, as long there is an implementation. So you can't have a partial method that returns a value, for example, string, but is not implemented later, because when it returns void, if you don't call the method, the method is erased, right? It doesn't end up in the final IL. But if it returns values, it can't be erased, so it might not be, or cannot be erased anyway, and so you have to actually implement it. And so what happens here is, for example, we have a function try convert, and it's being called, and it has out arguments, and it returns Boolean, and it's public, right? So all that is new, and you can do that in C# 9, and then you generate the code for it later. Okay, how do you write a generator? It's very similar to writing a source analyzer. If you've done it, it's very, very similar. It's the same API to access the CST, so it should be very familiar. I was doing analyzers. I have been doing analyzer for quite a while when started working with source generators it was really just understanding the little details and being productive very fast. If you don't know it, there's a learning curve, and it's not very easy at first, but it's an interesting challenge. And if you want to learn a little bit about compilers, this is really great, right? Because they made the API very friendly, but it's not simple, but it's a way to start. You know, this is actually a very approachable compiler. You work reading the compilation results, as I mentioned before, inspecting the CST, symbols, etc., and generating new code. You must use .NET Standard 2.0. This is a bummer because you can't use some of the new features from C#. Some of it depends on library types that are not available for .NET Standard 2. But it's actually it's not that bad. You know, the reason for that is that your source generator, it will run during the build process. Right, the build process is .NET 5, .NET 6, but to work inside Visual Studio, Visual Studio uses .NET Framework. So to be able to call it, it needs to be .NET Standard, which works both on .NET 5 and 6 and .NET Framework. So it's not that bad, actually. It's actually very, very fun. You can use most of the features. And this is a new thing in C# 10 and .NET 6. They created an incremental source generator. I will show it briefly because it's much more complex, but it allows for more efficient source generation. Before it caches the previous steps and only runs what's new. So this is really interesting. I just recently updated my example, and I will later on update my library to also work with the incremental source generator. So what happens is if you change some part of the code generation, it has to run the whole thing again. But if you have an incremental source generator, you can only run the parts that changed, and that makes it much faster. So it's using a memory, a cache, to only only work on what changed. Debugging a source generator, well, avoid it if you can. But if you need to, there is support since Visual Studio 2019 16.10. Okay, also works in Visual Studio 2022, of course. You can also write unit tests, which make you much more productive, much more productive. I really recommend you write unit tests. Okay, in the library that I published, you can find the base code to writing unit tests. If you're starting to do it, I really recommend that you do not work debugging during the whole process. It's really painful. Okay. Well, and you can actually get very productive with unit tests. And let me do a demo here. Okay, let's go. I will show you Visual Studio here. And let me just get my notes. Okay. So this is the project. Let me just give you a quick view of this project. So this is a new .NET 6 project. I updated it yesterday so you could see it. So what happens here is I'm creating a container for dependency injection using services that are with an attribute. Okay, so for example, this add service attribute, it adds the service as a to the DI container. Okay, this is a really simple example. The real library that I made, it has, you can opt in for singleton or the other scopes. Okay, but this only as transitional. So for example, we have two services here. This example service depends on another service, right? Another service has only a property with the values hello. Okay, so it actually returns this value on this get value property, and it's just simple as that. This add service, it's actually source generated, right? So you can see it here in the right. Add service is not generated. I can click on it and you can see it. But you can also go and click control click on it if you want to, and it will go there too. Okay, so this is I actually added an auto-generated comment. This is a good practice, okay, but also Visual Studio will tell you that it's a source-generated code, okay, but it's a good idea to always the name of the file should be .generated.cs, and you also add this auto-generated comment in the beginning of the file, right? So here you have the example service, and in the controller, I'm using it, right? I take a dependency on it right here, and then I add it as a field here, and then the index, we run it. Let me just run it so you can see it. Oh, I have to set the property here. It can start the dependency generation project. Let me just run it real quick before we, yeah, it's gonna run. While it runs, let's go to the program CS. Program CS has, this is the new top level statement program CS for C#. This has controllers. I saw you saw before the minimal APIs, right? But this is not minimal APIs, this has controllers, but the program CS is new, right? This new beautiful program CS is very much simpler than using startups. Yes. And this has a call to add services to the I. This method, it doesn't exist on service. This is new, this is mine. So if we go to it, let's click on it. There it is. This is auto-generated as well. You can see here on the right, it's auto-generated too. And it's adding those two files, right? So what if I, and I have the project running here, right? You can see the hello here. It's running. And on the view, just so you can see that I'm not kidding you. Here's the mod. So that's all there is to it. And that's it. And okay. And let me show you how this actually works. This is really interesting. Let's close this and put this here to the side. And let's go to this service. And let's just remove the first the first one. And you can see before I save it, it's already removed. Right? Let me just zoom out a little bit so you can see both. And I'll add it back again, right? And it's there. And let's remove one again, and then remove the other. The other one is removed. Now let's paste it back here. See, it's I'm not even saving, right? So I'm not even saving the file, and it's working. And you can see too here in the generator in the program CS, if I actually remove add services to the I, this whole file is removed. So now it's telling me that this file doesn't exist anymore, and you can see here that it's not there anymore. So if I add it back, I'm just snap this here. You're gonna see the file appearing up here again. If I undo this, and then it's gonna show up again right over here, and then it's showing up there. Okay. And again, if I
Giovanni,
wait.
Giovanni, sorry to interrupt. Your video is cutting a bit. Just 1 second. Let's see if you get better. Can you say something?
Let me
see if you get better.
Yeah, let me cut my camera.
Okay, can you say something?
Yeah, can you hear me?
Okay, yes, we can hear you way better. Thank you very much. Thank you.
Okay.
Yeah, you can continue. You can continue. Thank you.
Well, that's an interesting picture that showed up for my name. I'm not sure why that image is there. It's probably a bug in StreamYard. Anyway, so if I add back the service here, it's going to come back, right? So this is all logic I made when I was writing this, okay? So that's it. And let me show you how this is written. So we have a generator here. And you see the add service attribute. It's actually created right from the start, right? The code is all here. The code never changes. So it's added right in the beginning, right? So you create this from the start. It's always there. No real intelligence for this code. Actually, it's just there to help you so you don't have to write that service attribute for yourself. But the rest of the code, the one that generates the actual add scoped calls here, this needs some intelligence, right? For example, in one namespace do I add it? You can see that this is not in the top level namespace, the global namespace. But if the call was in a class inside the namespace, the namespace would be added here, right? Which is not in this case, right? But how do you do that? How do you do? So you actually create a service receiver, and then you use the service receiver here on the execute method from. But actually, you have to implement source generator, right? And source generator actually takes the execute method and the initialize method, right? So this service receiver actually will go and search for the code that you are going to work on, and then you can work on the execute method. So the service receiver, it's actually looking for two things here. It's looking for classes, right? So classes that might have the attribute that we're looking for. So it's gonna for every time the compiler finds a class, it's gonna call actually for every node that the compiler goes through, it's gonna call this method. This method has to run fast, right? So it's gonna take note of all the classes it finds, and then it's gonna also search for a call to add services to the I, right? Any call to add services to the I, doesn't matter whether it's made at. It's gonna just take note of it and record it on this invocation syntax property, right? So this is the new pattern matching from C#. It's really pretty, right? So it's taking an be made prettier now with C#10, but I haven't yet. But it's a way to parse the whole structure and then take note if it exists. And then in the generator, I'm not gonna go through the whole thing here because you don't have time for it. But I start searching for inside the syntax tree. I start searching for the attribute. You can see that here, and then I take note of the classes I find, right, and I create the service that scope. This is all string generation, right, and then I create the add services to the I method, right. So there's some work here to work with top-level statements. This is the no global statement syntax from C#9, and I also search it for classes and so on and so forth. And then this is just helper methods. There's just helper methods, and that's it. This is the whole code. Okay, this has like 120 lines plus the for the line, so less than 200 lines to produce that. Okay, and then there's the incremental generator. The incremental generator is much more complex. There's a pipeline that you have to work on. So you also have the class that's registered up front for that attribute, but then you have a pipeline where you're gonna grab the stuff you need, right? So you take some classes, then you combine it with the compilation. Then this is another step. Then there's another step here. So there are several steps that are being cached. So this step's cached, this step's cached, this step's cached. So all the steps are cached, and it only runs what it needs, right? In the end, you have a much faster implementation. This also works. You know, I actually produce tests. Let me show you the tests. These are the tests. You know, all the gruesome infrastructure code is in the base test. You know, for creating a compilation and adding reference, etc. This is not very interesting. So, for example, this test. So if there isn't a call to service generation, it doesn't check for anything. You know, I should only have the attribute. But if there is a call, you know, for example, if I had this code, right, with a one call to add service to the I, then it expects that the attribute is generated and this empty method is generated. It gets more interesting. For example, if I have a service, right, it should have then the registration for that service, and you can see that the namespace is added, right? So and down there we have one that's not for namespaces, right? Generated here two services, and then two services here, and let's see one that's more interesting here. Oh, see here we don't have the namespace, so the generated code does not have the namespace also. And there is one test for top-level statements, right? So here's the example, and here is the code that's supposed to be generated. So you have full support, and when you run the tests, they run as you expect, right? So if any of you is going to look for this code, just make sure that if you're not testing incremental source generation, that the normal one, you have to change it here, right? Because here it is testing the incremental generator, but if you want to change the other one, you have to change. I haven't created infrastructure to make this automatic. And finally, let me show you in Visual Studio code. So this is exactly the same code, same files. So if you come to iService to it finds the file now. You didn't used to find it, but now it does. And same thing for the models, right? It work, that service attribute, it works, it shows it, and you can build it on the command line, and it's gonna work just as expected. The build from .NET Build just works, right? You don't have to worry about it. It's the same compiler, it's the same pipeline. Everything just works. Okay. What's not very nice that I mentioned before? Let me close this. What's not very nice is this. If you have a NIM project, source generation, so you have to have a project, right? You cannot have this source generator inside the same web project here, for example. You need to have it in an external project. You just add the reference to it, just like this. You just have to mention, that it's referencing output assembly files, output type is analyzer. If you don't do this, this doesn't work. Okay. But what happens is, if you change anything in here, you have to close Visual Studio and open it back again. And it's really painful to do that all the time. Visual Studio 2022 is actually much faster to do that, but it's really painful. So you change something, then you close Visual Studio, open it back. It's really painful. So don't do that. Don't do that only in the end. For the whole process, you should work with unit tests. Okay. And to debug, what you do is you choose the Piti injection generation project, right? And here you can see that it is, you have to add a Roslyn component debug. Okay, and then you can debug it. So what you do here is, let's add a breakpoint here real quick, so you can see the first initialization code, and it's not adding. I'm not sure why. Oh, it's taking the console. Okay, and then let's add that one again here, and then just debug it, and you're gonna see that file name or extension is too long. Well, I'm not sure why it's not working. It should work, but it will be, what you see here is just the debugging working. Probably some detail here that I'm not sure why it's not working, but it works most of the time. And you can always debug unit tests too. So you can just add a breakpoint here and come to the test explorer over here and just debug it. And then and it's also much simpler to debug a unit test, right? Because it's the code that you created in a very contrived environment, and it's much better to debug unit tests and debugging the using another project. So if you're gonna debug it, first debug the test and debug the project later, if you really need to. So this is it. My time is up. Let me give you some resources to study. All those links are in a GIST. So you go to bit.ly/rsg presentation, which stands for Roslyn Source Generation, right? So RSG presentation. Or you can scan this QR code. All these links are there. So the links for this example codes there. There is a link for the source inject project I made, which is a real project for dependency injection, if you want to try it out. And that's it. Jose, I know I am a little bit over my time, but if you have time for questions.
Yeah, no worries, Giovanni. Thank you very much. Let me put you here. Thank you very much. So, folks, if you have any question, please leave for us. We are going to get more 1 minute and wait for some questions. Let's see if some question come. Usual, very nice, very nice presentation. Pretty interesting. I think it was pretty good that we changed the time, the schedule, because we are going to have one other talk about Roslyn also. and I believe
Oh, nice.
your talk was set up the path already for our following talk.
Very nice.
So
Yeah,
okay,
and
I believe.
if anybody wants to talk to me, just hit me in Twitter. Jose, if you can, please share the link to Twitter because people might have questions later. Maybe somebody will see this presentation later, then can come back to it and just talk to me on Twitter because that's where I am all the time. And you can send me a direct message too. The Roslyn API is complex, so if you wanna start on it, just endure a little bit because it will get really fun. It gets really fun after a while. So I really recommend you try it. I've had so much fun work with this API.
Yeah, that's nice. I will drop your Twitter. We had a comment for you. Great talk, very interesting topic. But I believe
Thanks, Peter.
no other question. Okay.
Yeah,
So well, if you have some time, go to visit us in Thailand, Bangkok.
I sure
We
want to. It's in my travel plans. If I'm ever there, I'll call you, Jose, and then we can set up something. So maybe you can meet up there.
yeah, for sure, for sure.
Great.
Giovanni, thank you very much. I hope you have a good day.
You
Okay.
too.
Any last words? Any last comments?
No, just thanks for inviting and having me. See you soon.
Ok, see you soon. See you soon. Bye bye.
Bye
Bye
bye.
bye. Take care. Grande Gigi. Falou.
Falou.
Falou. Uh, Whoa, amazing. We finished with the two Brazilian speakers. So now let's bring the Thai speakers. Our first one is going to be Pete. Hello, Pete.
Hello, yes.
Hello,
สวัสดี
Sawadee Krap, Kapong.
สวัสดี
Sabadi Mai.
สบายดีค่ะ
Already. Okay. First of all, thank you very much to give us this talk again. I am adding your presentation here. Okay.
yes yes okay thanks
So I will be leaving the screen. You have half hour, so you can start.
okay so hi everyone yeah my name is Phi I'm from Thailand so today uh, I would like to share with you to talking about how to use the Azure function to connect the Azure AD using the Microsoft Graph yeah so Uh, my topic today agenda is what is Azure Function, what is the Azure Keyword, and what is the Microsoft Graph. And then we can do the demo that I prepare already for you. Yeah. Okay. So I'm not sure you guys may be familiar with the Microsoft Azure already. So now we just brief information for someone that didn't know what is the Azure functions. Azure function is like a serverless. It's about a function as a service. You can create the small function inside and then just deploy. And and for sure, the language you can do like a C Sharp, Java, JavaScript, PowerShell, Python, or other custom handler is mean like for example in Microsoft Learn you can find Go or Rust, yeah. And no infrastructure management that mean you don't need to provision the server or just deploy your code. Just focus the code and the function and business domain and then deploy it. Yeah, they have a many plan like a consumption plan, premium plan, and dedicated. But Microsoft will provide the free tier, free forever for Azure function. So I think for every developer or any researcher would like to create a proof of concept something you can use Azure function for testing. Yeah. Okay. And then what about the Azure Keyword? If we talk about Azure Keyword is like a secret storage. It means that you can store secret key and secret certificate or any variable parameter and keep it on Azure Key Vault. That means you don't worry about someone try to access your if you not give the username and password, your username password. And for sure, normally make either Microsoft does not see your extra I mean your data, because it's like a encrypt and only show you only one time. So I think is is the one useful for make the application uh, in secure way. So this and also they are two tier plans like a standard and premium. Okay, so I think this is the good one for, I mean the main one for application development. You need Azure Key Vault for sure. Yeah. Then the next one, this is the highlight for today. I think normally Microsoft will provide like a API that can link all the service, like all the Microsoft cloud services, like Microsoft Office 365, Microsoft Azure, Dynamic. I mean, any kind of cloud service, you can use Microsoft Graph API. So actually, the Microsoft Graph API is like a REST API or client library. That means uh, they provide API key. They provide the SDK uh, for almost the main popular or favorite language like a C Sharp, Python, JavaScript. To use is easy to develop something that link to um, Microsoft cloud services. So that means this is the Microsoft Graph, like a graph. I mean, like a library for extract the data. Yes, this is the main focus today. So today, why I would like to demo this one, because of I heard some developer ask about how to use the Microsoft Azure to read information from Microsoft Office 365 or Azure Active Directory, how to set it up. So I think normally we not touch it because of we are developer, right? But I think sometimes we can upskill a little bit more how to set up, how to config, instead of to wait until someone or infrastructure engineer to provide you. So that's why I come up with the solution information or just a simple use case. Okay, so today I would like to show you how to use the how to write the Azure function by C Sharp, and then read the data from Azure Active Directory, and we use the key vault to store the secret key. Secret key, that means we don't need to keep all the secret key into the application, either Azure App Service or Azure Function or any kind. We just store key, yeah, into the Azure Key Vault. Okay, so I will show you the demo step by step now. Okay, I prepare the source code already because of if it will take more time, but I will go to the Azure portal. Okay, just a second. I will share my screen. Okay, I hope everyone can see my screen, right? Okay.
Just a comment, Pete. We're still seeing the screen with the demo, with the
Oh,
presentation. I don't know if I'm sharing some code, but did not change it.
okay. So that means
I
cannot
I
share.
believe. Yeah, I believe you are sharing only your presentation. You are going to stop and have to share the entire screen, I believe.
You mean delete from my presentation first, right?
Uh, yes, I believe you are sharing only the presentation, right? If you are sharing, if you would like to share some code, I believe you have to share your whole screen.
Yes, sure. I will. I will. Yeah.
Mm-hmm. Yeah.
And then I will show this one. Okay. Uh, could you see my screen now?
1 second, not that. Oops. I still can't see your screen. Just 1 second. Maybe it's loading. Yeah, I still cannot see it.
Just a moment. I
Mhm.
try to.
You have the sharing screen.
Yes, I have a sharing screen here. Okay.
Okay, I think now something comes. Yes, perfect. Now we can see your screen. Okay, you
Okay.
are sharing the Azure dashboard. Okay,
Okay. Okay. Thank you. Thank you.
okay. See,
Okay. So now I just prepare everything already. Normally we will start with I mean okay. Normally we will create the user first. So I will just go to the Active Directory. That means we need to create the user for a specific uh, for specific application. So normally I go to app registration, and then I will create this one. I will create already this one, and then after that we can create secret key. Secret key, that means normally uh, they will I mean normally is provide the expiry date, but we can this is a good way because of normally we try to make sure that the secret key will expire soon, because sometimes when we someone try to hack and store our key, we can deactivate from this one. Okay. And also after we create the uh, the account that will link to Microsoft Graph, we will need to provide information like to permission, like a directory read and user read, because of if this is the secure way of the Azure Active Directory. Azure Active Directory provide that a lot of the step focus that to make sure that you you would like to allow this or that permission to any uh, to any user. Okay, so that's why we need to allow this permission for Microsoft Graph to read, because this is because my demo will show the user from Active Directory. Okay, after we create this one, we just come back here to the resource group, and then normally we will create the key wall here. This is the main key wall. We need to create the secret key because of we need the user that we create in previous, like a client secret key, tenant ID, and yeah, we need two things: client secret and tenant ID. So that and client ID. So that means we need three things, and that we normally you don't store any secret key like this. I mean, this secret key this into your application. You need to keep it and store into Azure Key Vault like this. Okay, and then after we keep this one normally, and then we come to Azure Function. This is the Azure Function, right? and the Azure Function will provide the configuration here. Okay, configuration. Just a sec. The configuration, that means you can show information. For example, these three things will link to Azure Key Vault. You see this one, and when I click edit, you just see I mean only, yeah, you can see only the URL name. All right, so that means anyone, I mean, cannot read the secret key, okay, because of we use this one. Okay, so that's mean now we try to link the secret key from Azure Key Vault into Azure Function. All right, okay, and yeah, so that's mean we have everything already to prepare. So we just prepare the function and key vault. Yeah, and then I just back and show you the my code to show you how to write some a little bit to read the Azure AD for Microsoft Graph. Okay, so I will stop sharing. Yes, and then I just share. Okay. Oh, sorry. Everyone can see my screen.
Not
You
yet.
can,
Not yet. She, your
okay.
screen isn't loaded yet.
Still loading, right?
Yeah, it's still not loaded yet. I
Okay.
don't know. Are you sharing already, right?
Yeah. So I'm not sure why. I mean, just a second.
Mm-hmm.
Um,
Let me see also. Yeah, just
I
nothing here.
not you can't see it, right?
No, I cannot see.
Okay,
My
just a
mic
second.
problem.
Okay. I'm not sure why. I mean, just
Mm-hmm. You can use the sharing screen, or there is something also new. Is a new feature that is share the device that is direct to the presentation.
I would like to show you from the Visual Studio Code.
Yeah.
I mean, Visual Code I have.
Mm-hmm.
I already did, but I
Yeah.
try to, but I'm not sure why I can't.
Yeah, so in this case, you want to share your screen.
Okay, so I think
Uh,
okay, I will just find another way now.
mm-hmm.
Just a second.
Okay.
Just a second. Sorry. Yep. Okay. So I just like a function. Okay, I will try another way around here. So I think it would be I just copy my code into the Chrome. Did you see
Mm-hmm.
my screen?
Yes, I can see. Uh,
Okay. So okay, now it's time is raining. Raining is coming now. Okay. So okay. So right now, I just show you the function that I did. Normally, we need to add the graph API here. Okay, this is the graph authentication here. All right, so we need a graph here for authentication, and I just create the simple, easy for this demo. Like I would like to get to read the data from Graph API. Graph API will send like a JSON, so right, JSON information, and then I will convert and mapping to only this property. Okay, and also I just this is the main thing that I would like to mention. Okay. Okay, so that means normally we don't put any code in the source code, right, or any app setting, right, and but we put in the configuration. That means only authentication user that uh, that have a permission. So that means we can use the environment class and get environment variable like this and like this. So that means it's easy for us to track, to read the secret. I mean secret data here, and after that we just use like the confidential to make like a credential client uh, before we put that into the cloud service client to get the instant, and then this one. Okay, and then after that for this one I just put a little bit code from the previous, like call the method, and then now I just use the request from the graph client here, and just limit the data only, and then I put in the list of the class, and then I just display right into the Azure function easily here. So that means I I will show you the result after I run this short code. Okay, and uh, then I will put the result here. So I just stop sharing first to change the tab here. But you okay? Just a second. Uh, okay, here. Did you see my screen, right?
Yes, you can see.
Okay, okay. So that means when I come back to Azure function, right, we have a get function URL here. This is easy for the like a servlet function, and then I just paste here, and just wait a little bit, and then uh, we'll read the data from the Azure App Queue here. For example, here. Okay, so this is one how, and how can I know this is not the mock-up? This is come from the exactly Azure AD. I just back here to go to Azure AD here, and then I just show you the user. I just create the user here, and for example, if I create uh, the new the new user, for example, I just create the test, right, and this is the test, right, and create here. Okay, and then when I back to the get function here, and then oops, sorry. Okay, okay, boom. So that means this is the case that some scenario that you would like to synchronize data or transfer data or try to use the Microsoft graph uh, Microsoft Graph API to connect to the Azure Cloud Service. You can use Azure Function. You can use Microsoft Graph API to connect it. So this is the way how to do it. Okay. So that's, yeah. So I think So this is the way how I do. So this is my reference, and yeah, and that's it from my presentation. And thank you, and sorry for inconvenience that some I mean connection problem.
Okay, Pete, no problems. First of all, thank you very much for the presentation. Was the first time I see something related with the Microsoft Graph, right? And also, it's always good to see some of the service that Azure offer for us. So I
Yeah.
will ask for the audience, do you have any people in the audience, YouTube or Facebook, do you have any question? We have one here. I don't know if it's too much related, but my friend is from Marcella. She sent this question. My friend asked me if you don't know about anything about browser session, if Microsoft still make this implementation. I don't think it's related with the Microsoft
Microsoft Graph,
Azure. Yeah,
Microsoft
something
Graph,
like that.
right? But normally browser section, I mean, normally come from the application inside. In application inside, that means that the tool try to monitor the information traffic. So I'm not sure that, but I deleted the Microsoft Graph one. But for the application inside, you can see the user section. I think the browser section also.
No,
Yeah.
okay. Okay, so in this browser session, we're talking. Okay, application insight is more something analytics in this
Yes.
case.
Yes. Yes. Right. Right.
Okay, that will be where I talk about user session, browser session, and some
Yeah.
other user
Yeah.
information. Right. Folks, any other question? No. No. So, Pete, thank you very much. It's always good to see you. Uh,
Okay. Thank
Thank
you.
you to being representing Thailand today,
Yeah.
and I'm looking forward. Definitely, one of the first thing when I be back in Thailand will be reach
Okay.
out to you. I know I own you some since
Yeah,
the
that's
conference.
okay. Yeah,
Yeah.
yeah.
But
Thank
in
you.
my skills, I can say that we have some T-shirts. We have a lot of T-shirts. And people in the audience, also during the year, we are going to be giving away some T-shirts of the .NET Thailand.
Yeah,
Okay.
yeah, sure. Yeah.
Okay. So Pete, kapuna
Okay.
kap,
Thank
kap.
you. Thank you.
Thank you. Thank you. Bye bye. See
Bye
you.
bye.
Okay, everyone. So let's move forward for our last session. I will bring you Will to the stage.
Hello,
Hello,
everyone.
Will.
Hi, Jose. How are you?
I'm fine. I'm fine. And about you?
Yeah, doing great.
You are doing great. Well, do you know how to say hello in Portuguese?
It's O-O-O-L-A, right? O with the
Yeah,
accent mark
yeah.
L-A.
Olá, or
I
oi.
guess.
Yeah, can you sing that oi for our Brazilian audience today?
Hola.
Oh,
I'll have another Portuguese word in my presentation. We'll see if I got that one right. I haven't checked with anyone.
okay, that's nice. Thank you
Tell
very
me.
much for the joke. I assume you can share your screen with
Yes.
me. I can edit. So, for everyone, this is our second talk about Roslyn today. Roslyn recently is a very hot topic, right? So, Will is going to share a bit with us about uh, how we can create developer tooling with Roslyn. I can see our screen.
All right.
Okay,
Great. You
perfect.
can see the
So,
presentation.
guys, we can see the presentation. Thank you very much. I will be leaving the screen. The stage is yours.
All right.
See
Thanks, Jose.
you. Thank you.
All right. Hello, everyone. Good evening if you're in Thailand. Good morning if you're in Brazil. So today we're going to be talking about building developer tooling with Roslyn. And it's a great coincidence, I guess, that this really works well with the previous topic we had on source generators. I think it'll tie together really nicely. All right. So a little bit about me. My name is Will Fuqua. I'm the head of engineering at JetAbroad out of Bangkok, Thailand. You can find me online on GitHub, and then from there you can go out to various other websites, Twitter, stuff like that. So I am not Thai, but I have been working in Thailand for about 8 years, so I definitely consider it my home. So I'm working on an open source project right now called C# REPL. This presentation is not about C# REPL, but it's more about how you can use some of the technologies behind this tool at work or at home to automate developer operations, right? Automate refactorings, static analysis, stuff like that. So I'll just show C# REPL real quick. So this is just a little C#, I guess you call it REPL, a read eval print loop, right? Where you can say, maybe type in some code, has some syntax highlighting, stuff like that. And then it has a whole bunch of little nice features, like I want to go find the source code of datetime.now. I can press F12. It's going to navigate me to GitHub directly to the datetime.now source code. Works for like NuGet packages, anything like that, right? Built-in .NET SDK methods. So this is all built on an open source technology from Microsoft called Roslyn. And so Roslyn is Microsoft's compiler for C# and Visual Basic. It was released back in 2014, so it's not a new technology, but it is just very popular. It's continuously improved. It's open source here. And so this is the code that's running on your machine when you're compiling C# or you're compiling Visual Basic. It's open source, and you can download it if you'd like, and even you can reference it on NuGet. So we're going to learn a little bit about that. Okay. So this presentation, we're going to talk about what you can do with Roslyn, what are the various APIs, what it is, and then also how you can use these APIs in your own tools to automate your work, automate your open source projects, things like that. So before Roslyn, right, when we had an older C# compiler, and this is the way a lot of other compilers work, you input your source on the left side, you have your C#, your VB, you input that into some compiler, usually some command line compiler, and then out pops the other end an assembly. And it's a black box. You can't really see what's going on there. You just input source code, output binary. Roslyn makes that black box more white box. You can actually see what's going on inside. And beyond just seeing what's going on inside, you can take advantage of all of these libraries and classes and stuff like that inside the compiler, and then use it in your own code for your own static analysis, your own source generators, all that sort of stuff you can reference from the NuGet, from the Roslyn compiler. So our custom developer tools can reference these and then not have to re-implement a whole bunch of stuff and figure out a whole bunch of stuff via regex. You can actually use compiler APIs to be more efficient and faster. So there's a bunch of different APIs in Roslyn. I've sort of divided them up into 4 main areas, and we're just going to go briefly through these 4 main areas and see what you can do with them and have some code examples and projects like that. So the first one is the compiler API. So to start out, let's imagine we are compiling some code, right? Maybe we just start out with something very simple, 5 plus 3. So a compiler is a program that's going to turn this into some sort of binary or some sort of assembly. So how would the compiler model this code? What would the domain model of this code be? You could treat it as a string, right? You just file.read all text, right? You have your code, but that's not a great domain model, right? A compiler needs to go examine the code. It needs to go actually generate binary, generate IL from that code. So this is not how we're going to model the code. Instead, we're going to model it into a syntax tree. So in this case, this is a syntax tree representation of this code over here. We have a plus sign, and to the left of the plus sign, you have a 5. To the right of the plus sign, you have a 3. So this is like a model, a hierarchy. I mean, you can consider it a domain model of the code. So now let's look at some actual code. 5 plus 3 is very simple, but let's actually look at some C# and see how that would be modeled in real life. So this is actually also modeled as a tree, but as you might imagine, for C# code, it's a little bit more complex, although it's still not too bad. It's big, but we can understand if we go through it quickly. We have some expression, and then we're invoking some method, right? Console.WriteLine. And then we go down here, we can see, we say console.WriteLine. We provide an argument list. In this case, we just have a single string literal expression, hello world. And at the end, you have a semicolon and then maybe a new line. So it's all just a tree, right? Whenever you're working with code, it's all just a big model of a tree representing your code. And this is how the compiler represents your code. So now if you know SharpLab, this is a great tool. We can play around with this and see this. So here I have 5 plus 3. I can see that this is how the Roslyn compiler represents it. You can see literally we have this add expression. We have a left and a right, just like we had in our presentation. And then we can go down here and see to the left is 5 and to the right is 3. We can also do something a little bit more complex, like console.writeLine. And here we see that same slide here, but in tree format. So you can see we have our member access expression where we say console.writeLine. We have our argument list. So sharplab.io is a great tool for just exploring how the Roslyn compiler represents your code. Okay. So now the great thing about representing our code as a tree, right? You might think, oh, that's interesting, right? Like the C# code as a tree. But where that actually gets useful is now we can use Roslyn's understanding of our code along with LINQ to query in our program structure and even modify our program structure. And this is exactly what source generators do in the previous presentation, where we talked about being able to look at your program and generate code. You're just generating this domain model. You're generating this tree using Roslyn's APIs. So let's look at an example. So for example, we have console.writeLine hello world, just here as a string. We could maybe have read that in from a file, from a C# file, but we have some string in our program and we want to analyze it. We're going to do a little bit of static analysis. We're going to say, we want to find what is the string that we're going to be printing. Now, if it was just this simple, you might be able to use regex or string.splits and do it. But if you think about a whole big file or all the possible types of code, you know, white space formatting, ignoring comments, it gets pretty complicated if you want to write this from the ground up. So we're not going to write it from the ground up. We're going to use Roslyn to go figure that out. It's really simple. It's just these 2 lines of code. So we have our tree. We get the root of the tree, and then we can just use LINQ. We have descendant nodes here, which returns an I enumerable of nodes. We can use of type and single from LINQ just to go find our literal expression in this case, hello world. And then we know we only have one in this program, so we're just going to go cheat a little bit and say single. And now in this message, we will have our WriteLine string. So this is a way that you can analyze your program using LINQ and using Roslyn to understand your program and find more interesting static analysis opportunities. You can make it a little bit more interesting as well. And here's where I'm confident of the Thai on this slide. I'm not so confident of the Portuguese, but I'm pretty sure mundo is world in Portuguese. Correct me if I'm wrong. But so we're going to change hello world to sawatdee mundo, right? Sawatdee is hello in Thai. And presumably, if I've got this right, mundo is Portuguese for world. All right. So it's really simple. So we have our message from the previous slide. All we need to do is make an object that represents our new string, and then just call replace node on the old message with our new message. And then we can get the string, console.writeLine, sawatdee mundo. And one thing to notice about this is immutable, right? When I call replace node is not doing a replacement in place, right? I get back a new program. So this is something that maybe trips people up when they're first working with Roslyn, is that if you go modify a syntax tree, you're getting back a new tree. You're not modifying in place. So just watch out for that if you're doing a little bit of Roslyn coding. So I'm actually going to switch to Visual Studio here, and we'll just see that in play. So this is our input program, right? It's just a very simple top-level program saying console.writeLine hello world. Here's our program, which we just saw the source code of, where we read in our input, just like we saw. We parse that into a tree. We go ahead and find the string we're printing with LINQ. So we say descendant nodes of type literal expression single. So that'll now represent, we've queried our program to get this hello world. Then we make a new string with our message, sawatdee mundo. And then we just call replace node, getting back our new tree. And then we write that to a new file to get the full string of the program. So here is our program. I'm going to go ahead and delete the existing output. I'm going to run this program, finish it pretty quickly, go over here, edit the file. And you see now we have our new program. Our input program was console.writeLine hello world. Our output program has replaced the string using LINQ and Roslyn to modify our program. Okay, so that's like a hello world program, right? Like it's very simple. We've used this, we've used Roslyn in a couple different places at work. The public one that you can go take a look at if you want to go look at it open source is this NUnit to XUnit converter, where we had a bunch of NUnit tests. We wanted to convert it to XUnit. It's all pretty simple, where you have like a test fixture, you have a setup in NUnit, you want to get rid of those attributes. But then it gets a little bit more interesting, because in NUnit, you have a setup method. In XUnit, you just use your constructor. In NUnit, you have a teardown method for cleaning up. In XUnit, you use an iDisposable implementation. So you have to add iDisposable and then change that to a dispose method. So we used this. You can go take a look at it. And we use the compiler API to write that and then convert a whole bunch of tests. We've used it in other places, mostly for static analysis, to find interesting, gotchas in our code base. But this is probably the one that's the most interesting. You can go take a look at. If you're using this at work, for example, to go do some sort of refactor or static analysis, I think the Pareto principle here is your friend. The Pareto principle states that the hardest 20% of the code takes 80% of the time, right? It's also called the 20-80% rule, where 80% of the work you can get done pretty quickly, right? But that last 20% is hard. That's sort of the approach we take when we're doing these automated refactoring tools. And you can spend a whole bunch of time automating, 100% and making sure you cover every edge case. But we found if you're just doing, some one-time work, you're not making a general purpose reusable library. Even if you just automate only 80% of the work, and then you do maybe 20% maybe manually if it's a hard edge case, something like that, that's actually a huge win to automate 80% of the work quickly. So I'd recommend, if you're doing some of these refactorings, just do the easy case. That happens a lot, and that's a good approach for doing some of these refactorings. Of course, if you're doing a library, something you want to go share out in the world, right, then you maybe need to focus on correctness. But just for little ad hoc scripts and stuff like that, consider this approach. All right, so that was the compiler API. Next, we have the Workspace API. Workspace API is much more simple. The Workspace API is basically a solution and project domain model. So you can open a solution with Roslyn like this, and then you can go query the projects and the documents in the solution. And then from the documents, you can go get the source code of those documents and then use the compiler API. You can also use the Roslyn API to make new projects, make new documents, stuff like that, insert documents, delete documents. So if you do want to work with more of like a Visual Studio project document solution, right, or a .NET CS Proj sort of thing, you can use the Workspace API. It's very simple. So we've used the Workspace API. We had this very large code base that we got, and a contractor had originally written this. They had defined all the unit tests in the same file as the system under test, which, maybe that makes sense in certain cases. It's not something we want to do. A complicated deployments. It was a little bit weird having these pragmas that if you had the right symbol set, it compiled, or it didn't compile. So we wanted to set it out into maybe a more typical Visual Studio or CS Proj style, where you have a test project and you have like a project that's your system under test, two separate projects that somewhat mirror each other. So we use the Workspace API for this to go through and just we yank out this if unit test and then create new projects and documents that mirror it to go split these out into two different projects. And that way we could have our mocking libraries, our test libraries isolated in test-specific projects, and didn't have to worry about, mocking libraries somehow making into production or something if something's misconfigured, stuff like that. Okay. The last one that's interesting about this in the Workspace API is the syntax highlighting API. It's a really neat API. We'll have a demo for this. I'm going to switch over here to the highlighting demo. So what we're going to do here is we're going to programmatically syntax highlight some code. So I have some sample code here. It's just a string. So it's a class program. We have our static void main. We have a console.writeLine hello world, and we have a comment. And we're going to print this out to the console, but syntax highlighted. It's really simple to do the syntax highlighting. It's just here in this step 2. We have this classifier API right here. we just call get classified spans async, passing in this document and saying that we want to syntax highlight all of it from 0 to the length. And so from there, we get that classified. It's going to tell you, oh, from character 42 to 47, that's a keyword. Or from character with index 65 to, 85, that's a comment. It's going to classify that for you. And now in this case, we're just going to look at some of those classifications, assign each classification to a console color. So now when I run this program, now you see it's printed out this string here, but it's printed it out in color, right? So we have our class program static void main, we have our comment. So that's a really nice way of syntax highlighting code from any application. In this case, we syntax highlighted to a console, but you could very easily change your renderer and make your renderer output CSS or HTML tags or whatever you want to syntax highlight. All right, next up we have the diagnostic API. Diagnostic API is what you usually see in Visual Studio or Visual Studio Code. You might see a little light bulb or something in the little margin of your editor where it says, hey, you could replace this string.format with an interpolated string, or it might say, hey, that might be, you can simplify this name, or you can remove this cast, right? We've probably seen that all over the place in our various editors and IDEs. The diagnostic API is how you can write your own diagnostic analyzers, both to identify the problem and then also suggest a fix, right? In this case, it's identified a problem and it's also written the code for you to fix it. And you can use the Roslyn API for that. And of course, you use the compiler API, which we already talked about, to go query the code and find those cases and make new trees that then have this interpolated code, this code fix. I'm not actually going to go through this too much because Microsoft has an amazing documentation for this. Like, it's probably some of the best Roslyn documentation out there is how to write your own diagnostic analyzers, which find the issues, and code fix providers, which automatically fix the issues. You can distribute this as a NuGet package or a Visual Studio extension. Nowadays, we're seeing a lot of NuGet packages bundle some of these diagnostic analyzers. So when you install the NuGet package, you also get recommended static analysis and recommended fixes. If you're curious about this, go check out this hyperlink. I'll have this presentation available after the talk, and you can go walk that through, and it gives a really great detailed tutorial of how to do that. All right. Finally, we're going to talk about the scripting API. Now, the scripting API I really like. That's what I based my C# REPL project on. And so we're just going to go straight to a demo for that. Okay. So I'm going to start this up. First, I'll just run it so we can take a look at what it is. So this is what you call a REPL, a read eval print loop. You also, sometimes you call it C# interactive or F# interactive, like that. I think interactive is a popular name in .NET. Basically, what it allows you to do is you can type in some C#, right? Maybe I'll type in some more C#. And now I'll do an interpolated string. And it allows me to reference the previous lines, right? So I can sort of build up some code and play around with it, interactively iterate on code, explore APIs and stuff like that, right? You do datetime.now, right? Or apparently you can't do datetime.now. Oh, I didn't import using .system. I have to say using system. Say using system, right? Now I can say datetime.now. Right, it's going to print out now. Oh, I only have about not so much left in my presentation. So now the code is really simple. So this is the entire code for that program we just saw, to go accept the input, evaluate the code, and then print out the result, and then keep the state between each line. So you can see here, we have our state that's used across the program. We have an infinite loop. We read some input. Okay, we allow the user to exit because we're nice. And then the first time through, we run the script and then store the resulting state in script state, right? So the first time through, script state is null. So we're going to say C# script.run async. Then subsequent times through the loop, script state will not be null. So then the other iterations will use this. And we will take our state and we will continue with that state with the input, right? So that will then run this input in the context of this state. This continue with async is not related to the similarly named task like continue with, right? This is specific to Roslyn about state management. And then finally, we output the return value. So it's a trivial amount of code, right? It's like, 17 lines of code here to write a pretty decent read eval print loop, right? Not too far off from CSI and some of the REPLs and interactive programs built into Visual Studio and available to command line, things like that. And it's available because Roslyn, our compiler, can be used as a library. So you see, for all these projects we've been doing, I've had just package reference. I just reference Roslyn under this Microsoft Code Analysis namespace. And then I get all this functionality. So you can go, for example, go take a look at highlighting, right? We just reference a slightly different NuGet package, right? But it's still one of the main Roslyn packages. Same here in the first one we looked at, right? I'm just referencing NuGet package, and then we get all of that power of the Roslyn compiler available for free in our applications. Okay, so now there are a bunch of enhancements we could make, for example, with the scripting API, right? We saw that error I had earlier where I forgot to say using system, right? We might make sense to have a default set of usings so the customer, for the user not having to always type in using system, right? Or maybe some assembly references. There's all sorts of interesting things we could get into about importing files, right? Allowing references. I've done all of this in that open source project C# REPL that I showed before, right? You can do syntax highlighting, IntelliSense. We can do like some more semantic understanding of our code. All of this stuff is available as Roslyn libraries on NuGet that we can add to our own code. All right. So here, if you're interested in this, you want to look at some of the more interesting developer tools that use Roslyn, you might be interested in some of these programs, right? This is the program that I showed, right, that I'm working on called C# REPL, right? There's also a .NET Interactive, which runs similar to like, well, actually it is like a Jupyter Notebook, right? You might know a Jupyter Notebook with Python programming. .NET Interactive is the equivalent for C#, F#, and PowerShell. There's .NET Script, which is probably one of the more popular REPLs out there for running C# as scripting code. And then finally, you can program C# in VS Code, as we all know, also Vim, right? And that's all powered by this project called OmniSharp, right? In Visual Studio Code, C# support is just a plugin, as you may know, and it's powered by OmniSharp, which is using these same Roslyn APIs to provide an editor experience and provide all these amazing IDE features. All right, so that's all I have. That's my talk. Any questions or comments?
Amazing talk, Will. So for the audience, if you have any comments, please, or any question, let me know. Okay, let's wait a bit to see. Will, are you in Bangkok right now, right?
I am, yes. Yes, I'm in Bangkok.
That's nice.
Right.
That's cool. Yeah, Miss Bangkok already.
Yeah.
I'm not sure if no questions. Will, I have a question for you from myself. Any plans to write any kind of new book about Roslyn or about some developer tools about anything? Is something you are in your pipeline? Or
I don't have any books planned. I'm focused on writing like actual tools at this point.
Mhm.
I think it would be interesting. There's a lot of good material out there from if you are interested in more reading materials, right? You might be interested in. Let's see if I can find him. one moment. Strathweb.com. This guy has like a ton of great reading materials. Let's see. I will share my screen again.
Mm-hmm. Yep. Perfect.
This guy, strathweb.com, right? Philip W., .NET developer. He's really active in the Roslyn repositories, right? And he blogs a ton. I wish I could be as prolific a blogger as he could. And so he has a lot of good articles about how to use Roslyn and how to, maybe write a Blazor application so you can compile C# in your browser, right? He has a ton of great, interesting articles on it. And it's just a great blog to follow anyway. So if you do want some interesting books, right, or at least blog
That's
posts, he's
nice.
got to take a look at.
Mm-hmm. Yeah, that's nice. That's amazing. Yeah,
I saw you already linked my book in the comments, right? Like,
yeah,
sorry.
I link some books, some other things, and also just a comment for the audience. Every time if you see some GitHub repositories of projects that you like, please give a star. This helps a lot. All the open source maintainers, right? Yeah.
Yes,
So
definitely.
yeah. So I invite everyone here to give a star for C# repo. I use on my machine few years ago already. I use and is very. I remember before was very the installation was a little bit complicated, and I saw you started you package and wrap everything the installation.
As a nice
And
.NET global tool. Yeah, I love those global tools. Yeah.
yeah, exactly. And constantly I've been using on my local machine. Sometimes you get to like, okay, I want to do a datetime.now, what is the difference from datetime.now, datetime offset.now, and this kind of thing is very, very useful, right? Well, looks like no questions for you. So Will, thank you very much. It's
Yeah,
always a pleasure to see you. Your content is always
appreciate you
interesting.
putting this on. So thanks, and I'll see you guys later. Bye.
So see you later. See you later. Bye bye. So everyone, I believe we arrived into the end of this. Let me try to put it right. Yeah. No, I'm not sure if you can see me better, but we arrived into the end of this presentation, right? This is important, very important for all of you in talent. So I just have some other messages to say. I would like to say thank you for Jetabro, Thoughtworks, Lambda, Agoda, 7-Peak Software, Gambir, and Manao Software for all the support you folks have been giving to us. Also, a special speakers, a special thanks for our speakers, Vitor, Giovanni, Pete, and Will. Was a lot of work to arrange this intercontinental meetup, but I hope you all enjoy it. And for the last, I want to send a hi and a thank you for the SDK and GPS team, special Erica, Juliano, Marcela, Vanessa Metonini, Will, and Noronha. So thank you very much for being part of that. I hope you had enjoyed, and I see you next month in Bangkok. Right. Just a reminder, always the last Monday of the month. Right. You have the .NET Bangkok Meetup. Sometimes we had to change the date because some other arrangements. But usually we are back on the last Monday of February. Okay, so thank you very much. Hope to see you all. Bye bye. Kapuna krap.